Welcome to this GCSE Physics video on the particle model of matter. In this lesson, we'll cover key concepts including density, changes of state, internal energy, and how gases behave under different conditions. Changes of state are physical, not chemical. This means no new substance is formed. The key processes include melting, freezing, boiling, and condensing. These changes are all reversible. Density is how much mass is packed into a given volume. It's calculated using the formula, density equals mass divided by volume. Materials like metals are denser because their particles are packed more closely together. The law of conservation of mass states that within a closed system, the total mass remains constant over time. Matter can neither be created nor destroyed, only rearranged. To find the density of regular objects, measure the dimensions and calculate volume. For irregular shapes, use a displacement can to find volume. Always measure mass with a balance and convert units properly. Internal energy is the total energy stored in a system's particles. It includes kinetic energy from movement and potential energy from particle positions. Adding heat increases this energy. Specific heat capacity tells us how much energy is needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius. Water, for example, has a high SHC, meaning it stores lots of energy. In experiments, we measure the energy transferred by a heater, the mass of the substance, and the temperature change. With these, we calculate the specific heat capacity using the SHC formula. Latent heat is the energy needed to change a substance's state without changing its temperature. The specific latent heat of fusion relates to melting and freezing, while vaporization refers to boiling and condensing. Gas particles move randomly and quickly. As temperature increases, their energy and speed rise. These collisions with container walls create pressure. Pressure in a gas increases if the temperature increases, assuming volume is constant. Likewise, decreasing the volume of a gas increases pressure, as particles hit the walls more often. Boyle's law states that for a fixed mass of gas at constant temperature, the pressure multiplied by the volume is constant. If volume goes down, pressure goes up. At the microscopic level, gas pressure is caused by gas molecules constantly colliding with the walls of their container. To sum up, the particle model helps us understand how matter behaves during heating and state changes and explains the behavior of gases in terms of particle motion and energy. Thank you for watching.